Okay, in this video we're going to explore console input, console output, and declaring and using variables in our programs. The objectives are basically exactly what I've just mentioned. We'll review what we've learned through the Hello World lecture. Hopefully you've watched that video and you've gone through all of the setup that you need for Visual Studio on your machine. So we'll have a look at that. We'll talk about how to declare and use string variables in this particular case. We'll talk about variables of other data types in future lessons. We'll learn how to capture input from the user. In this case, since we're creating console programs, we'll be capturing input from the keyboard on the command line. And we'll also look at how we can display those variables back to the user. So let's get it. All right. So I've already got Visual Studio open here, as you can see, and I've also got a Word document open with a very simple problem statement that we can use to work through this example. We'll start with that first, and we'll go through the steps that were outlined in the problem-solving activities process, just to keep ourselves up to date and to keep that problem-solving activity mindset in the back of our minds always. So on some of these lesson videos, I might not go through all of the steps in the problem-solving process, but I do want you to keep that in mind when you're at home working through the exercise problems on your own, and make sure that you're following those activities. Especially if you're new to programming, it's very important that you get in the habit of following through those activities. Planning, and planning. If you don't have a good plan, it's very difficult to sit down and then start to create your solution. So if we have a look at the problem statement that I've specified here, it's pretty straightforward, and it follows closely what was used as an example in the lesson that's on Moodle as well. And so what we're being asked to do here is to just simply create a program that will ask the user for their name and then display a greeting including their name back to the user. So we can start with this as a simple statement and just read through it. I mean, it's easy, it's only one sentence, but again, it's good habit to go through the practice of applying those problem-solving activities. So when we take a look at this statement, we can see we're being tasked to do a couple of things. One, obviously that we're being asked to create a program, but there's some individual tasks that we're going to have to take on. So specifically here, we're going to have to ask the user for their name. So that's an important piece we're going to have to keep in mind. And then we're going to have to put together some kind of a greeting string that includes their name, right? And so that's kind of the next piece. And then, of course, the display in that underlined piece of the sentence there indicates that we're going to have to somehow get that back out. Some kind of output's going to have to go back to the user. And so then just to make sure that we've kind of understood this problem, that we've modeled it appropriately, we can try to break it down. Again, we could use flowcharts, we could use a process diagram, or just scribble it out on a napkin, really. The important thing here is that you're thinking about the problem and how you might go about solving it. So before we go into creating a detailed step-by-step plan, we just want to make sure that we've got all the elements that are included that we need for this. So I'm going to just simply break it down into basically a text version of a process chart where we're basically going to be asked to get input from the user, and then we're going to be tasked with creating a display, a greeting. Oops. And then finally we're going to have to display the greeting to the user. So those are kind of three smaller tasks that we can take this already small task and break it up into. And the nice thing about doing that, finding individual pieces to the solution, is you can start thinking about parts of the solution that you're already familiar with, and then maybe just focus on how you might go about solving those individual pieces, and then tackling some of the additional parts that maybe are new or you're not so comfortable with quite yet. Versus trying to put the whole thing together at once. So if we have a look at this, the idea of displaying a greeting to the user, We already know how to do that. We've seen that in a previous lesson. We may have gone through some of the display exercises. So we could just even tackle that on its own and say, well, what is the greeting going to look like? How would we display it? And then we can go and move on to, okay, that's great. We display the greeting. How are we going to get a user's name into the greeting? And then beyond that, how are we going to even ask the user for their name? We haven't learned how to do that yet, but we can already achieve part of this solution. So we might want to decide to focus on that. So once we've looked at it and evaluated that I think this is going to solve our problems, then we could think about what a more detailed solution looks like. And for the majority of these lessons, I'm just going to be using pseudocode syntax. And all that means is I'll be typing, in a word processor like this right now in Word, and I'll be just using kind of broken English sentences, if that makes sense. It's not going to be an actual programming language, but I'll be using just short text statements that closely resemble something that we could implement in code. And on the Moodle site, I do have a PDF reference for a more kind of explicit formal introduction to pseudocode and how you could use that to complete these plans for yourself. And I'll try to stick to that pretty closely. But again, the point here is not to adhere to a strict pseudocode standard. If you prefer to use flowcharts or something like that, you could do that too. The point really is just to have some kind of a tool that we can use to model a plan more simply before we go into the code, where of course if we have syntax errors or logic errors, we're going to be beaten down by those. Doing it first as a plan in a Word document, for example, allows us to quickly get our ideas and our steps on paper without having to worry about fixing things as we go. So in this simple example, our plan might look something like the following. And we'll come back and I'll add to it as we introduce new topics throughout this lesson. But basically, we're going to want to prompt the user for their name, whatever that looks like. We may want to then create a greeting string, and then we're going to want to display the greeting string. So this isn't, my typing is pretty bad. This isn't what the pseudocode standard that I've posted looks like, but as a place to start from, it's okay to kind of, like I said, just get these ideas out on paper. And I'll be explicit here and say that we're going to display that to the console. So what are the details for prompting the user for their name? Obviously, there's more to it than just that. I mean, that's what we need to do, but like, how are we going to do it? And as I introduce some of these topics in the lesson, we'll come back to this plan and we'll kind of clean it up a little bit. So at this time we can step back, look at it quickly and say, does that plan sound like it's going to solve the initial problem? And I think it does. It's pretty straightforward. Great. Now we're ready to break into Visual Studio and actually start writing the code to solve this thing. So if you don't already have Visual Studio open, I encourage you to do so if you'd like to follow along. And then once we're in here, we'll just create a new project for this. So I'm going to go from the File menu. I'm going to select New Project. Control-Shift-N would be the shortcut keys to get to the same dialog window. And then from here, we can just create a new name for the project. And make sure that you select the appropriate template. So we're going to be creating a C# console app. Make sure that's the one that you highlight. And then we can go on to Next. And then it's going to ask us for our project name. So again, I'm just going to call this Lesson01 underscore input underscore output underscore variables. Now, if you want to name your project something else that's more meaningful for you, please go right ahead. At the end of the day, these projects are going to be on your system, and I want you to name them in a way that is going to make it easy for you to search through and find projects in the future going back that you want to go get information from. And of course, there's always these videos you can come back to, and I'll probably post the majority of these completed lecture video projects to GitHub or something like that, so you could always have a peek at them up there too. But this is the naming convention that I'm going to adopt for our projects in the course. It makes it easy for me to know exactly where we're at by numbering the lessons and then giving them a short kind of descriptive text in the name as well. I'm going to go with my default location. I've already checked the box for solution in the same directory, so I'm going to ask it to create that project for me. So hopefully this is a bit of a review for you from the Hello World project. And of course, here we go. We've got our code, we've got our scaffold ready to go. And again here, all we're really interested in, I'll zoom in a little bit, is writing our code statements inside of this main method that's created here. Again, these other pieces, they'll be described in more detail as we learn more about C# as a programming language and programming in general. But for now, we don't have to worry too much about that. We just have to make sure that we're writing our code statements in between these two braces. So this is going to represent the code block for our program, and all of our statements are going to have to appear in between these braces. We get a nice default console.writeline statement for Hello World. That's fantastic. So the scaffold for the program is really already giving us our third piece of our plan here, which is to display a greeting to the console. And so we can already kind of mess around with that and see how that's going to look, and do we understand how to get the output to display on the console. And then once we have ticked that box, then we can move on to the next pieces. So for now, let's just go ahead and alter this without worrying about steps 1 and 2. We'll just adjust the Readline statement here so that we get a greeting display to the screen. So I'm going to just click in here, and where it says Hello World, we'll basically just keep the same greeting for now. That's fine. I want to update it so that instead of saying hello to the world, it will say hello to some user's name. So if the user's name, for example, were Jane, then I want that to appear in the greeting outline or the Readline statement. And now, so that's fine for now. You're going to say, but that doesn't address the full problem, but that's okay. We just want to make sure that if we make these changes, that we're able to get the desired result from our Readline statement. So at this time, you could save the code. There's a nice save icon up here at the top, or you could choose to just run it and it'll save the project for you. And so when you click on the screen play button, it's going to launch that project into a terminal or a command window. Mine's opening on my primary desktop screen, so I'll pull it over here. And there we go. We can see that it's outputting the Hello Jane text, and that's fantastic. Now, this program as it is solves the problem of displaying a greeting for a user whose name is Jane, but doesn't solve the problem for a user whose name is not Jane. And so we need some way of abstracting the solution so that we can run the same code but have it display a greeting to more than just one individual. And this is really where variables come in. If this was the task to just write a program that displays a greeting to Jane, we could tick the box and say that we're done. But the kicker here is we don't know what the user's name is going to be. And yet we still need to write a program that can be run by any user and display back their name. So we need to basically put some kind of a placeholder in for the user's name. And that's really what a variable is. Okay, so I'm going to close this output window and get back here. And then if you just click inside the braces and hit enter, that'll format your code, put you down on a new line and tab in. While we're here, don't fight the editor on how it's tabbing your code in and lining braces up. That's all part of the formatting standards and guidelines for writing C# code. And I'll have a lesson in the future, maybe like a supplementary lesson on code standards and code formatting. But just know that for now, that's part of how we would expect the source code to appear. So just appreciate that the editor is trying to help you in formatting your code. If your code doesn't look exactly the way mine does and yet it still runs, that's fine. Don't worry about it. We'll talk about cleaning up the code later. For now, the most important thing is just getting programs that run. So what we need to do here is somehow say, hey, look, I don't always want to display a message to Jane. I need some kind of a placeholder for the user's name to appear in this position. And so what we can do is we can declare a variable that could hold any user's name, any value, and yet be placed in the same location where we see Jane here. And a variable is really just made of two pieces. One of the pieces is a data type, which defines what kind of values we can put inside the variable, if that makes sense. And then we also need an identifier or a name. something that we're going to use to refer back to the variable in the future. And it's good common practice to name your variables so that they have good meaning. And what that means is when I read your code or when you read anyone else's code, it makes sense. If we created a variable for the user's name and we named that variable Z, that wouldn't be very meaningful. I wouldn't understand what that means. But if we create a variable called username, well, that's very clear to me what that variable represents. And so this is where we're going to get introduced to our first formal type, which is a string type. And we've already used strings in our output. For example, the hello Jane that we have in our Readline method, this is a literal string value. And literal strings are held between these double quotes. So wherever we have characters that exist in between double quotes, we're going to refer to that as a string literal. And that just means that it's a string with this particular value, and it will have that value every time you run this program. But we don't want that. We want the string to vary. It's going to be different depending on what the user's name is. So to declare a variable, it's very straightforward. We start by defining the type, which for us will be a string variable. That's the type of data that we want to hold on to. And then we need to provide an identifier. So I'm going to use username as the identifier. Okay, and then we finish that statement. This is a variable declaration statement. We complete that statement with a semicolon. And that's it. We've declared our first variable. If you have a look at it, it's underlined with this green squiggly line. And all that is there is to say, hey, you declared a variable for this program, but you're not using it anywhere, which is fine. We're going to in the future. So green squiggly underlines, those are okay. Usually they're there to bring your attention to something, but probably it's not an issue that's going to crash your program or ruin your experience. So we'll deal with that in a moment. The second thing that we need to do once we've declared our variable is to assign it a value. So if we hit enter on the end of line 9 here, we get a new line again, and now we can assign some kind of a string value to this variable. So we'll just work with the value that we currently have displayed, which is Jane, and we'll assign it to this username. So we begin with the identifier or the name of our variable, which is username. You'll see that Visual Studio highlights it. It recognizes it as, hey, you've declared this before. I think you mean this thing here, and I do. And then follow that with a space, and then the equals operator. Okay? The equals operator, this is what we call the assignment operator. Okay? And it works like this. Whatever expression value we find on the right side will be assigned to the variable location that is on the left. Right? So we're not saying username equals something. We're going to be saying really, or reading the statement really as username is assigned some value. And it could be just a literal value, but it could also come from an expression. And we'll talk about expressions a little bit later on. But for now, we just want to assign it a literal string value. So here I'm going to create first an empty string. So just two double quotes right beside each other. It is a string value. This is just a string of 0 characters. So it's a valid value. It's basically just blank. But then within here, we can type in the name that we'd like to display. So username will be Jane. So now we've done two things. We've declared a variable and we've assigned a value to that variable. And now the third thing is to use that variable in our output. And so what we'll do is we'll get rid of the Jane part here. I won't worry about the exclamation mark for now. But if we delete that, we can see we've got the beginning part of our greeting, hello, with a space. And what we want to do now is right where my cursor is, that's where I want the username value to appear. So Jane is the value, but I don't want to type Jane back in here. That's what we already had. I want to say, take whatever value is stored in the username variable and put that in its place. Now, if we just type username right inside the double quotes, you'll notice it's still orange like the rest of the string. And those of you that have been paying attention will recognize that it's like, yeah, I put username in there, but anything within the double quotes is a string literal value. So what do you expect the output of this program as we've written it will be? I'll let you take a second to guess, and then we'll execute it and we'll see what happens. So if we run that program, we're just typing username right inside the string, and likely you guessed it, we're just going to see hello username. We've just swapped out the literal value of Jane for the literal value of username. So that's not what we want to achieve, okay? So we can't do this. We can't place our variable inside the string, at least not directly in this fashion. What we want to really say is take this double quoted string literal, so hello with a space, take that as a value, but I want to somehow join that together with the username variable. So here's the beginning of my greeting, and here's the username variable. And again, when I highlight it, you'll see it, the editor identifies it as being the same as these other two instances. So this is good. This is telling us that, okay, we're now using the correct variable. But we've got now this red squiggly underline now, and this, as opposed to the green one we saw earlier, is a bad thing. This tells us that there's some kind of an error, right? Our program isn't complete. It's not going to run until we fix that. And that's because we've broken the rules of the language or the syntax. So this is right now a syntax error. It doesn't know what to do with this. We have one value on the left, we have a variable value on the right, but we haven't told the computer what to do with those two values. And so right here in between the two, we can utilize an operator to create our first expression. And an expression is just that, any combination of values and operators that need to be evaluated before they can be used in the statement. And so what we want to do here is basically say, I like the hello literal string on the left to be, and we'll use the plus operator here, to be joined with the value that's in the username variable on the right. And you'll see as soon as we put that plus in there, the red squiggly line goes away, everything seems to be fine. And right now what we're doing is we're using this plus operator as something called the concat or the concatenation operator. It's not adding the two values together because, of course, addition is only done with numbers. So what this is doing is it's concatenating two strings together to create a new string. And we'll talk more about strings and concatenation with numbers in the next lesson. But for now, all we need to know is since we have a string literal value on the left and username, which is also of type string, is on the right, what this operator is going to do is take this first string, join its value with the value of the username string variable, and create a brand new string that will actually be passed in to the Readline method. So when we run this program again now, we should see that the username isn't displayed, but that we get the value of Jane displayed instead. And so here we go. We're back to kind of where we started, minus the exclamation mark. Okay, and so that's really it. As far as declaring and assigning values to variables, there's nothing more to say than that. When we have different variable types, we'll talk about different values that we can assign to those variables, but the process is exactly the same. And also for outputting variables, the process again is the same. We can use this concatenation operator. There's other alternative methods of getting output, and I'll explore those with you in the next lesson. But for now, using the plus operator to concatenate two strings together is going to work just fine. So at this point, we've kind of tackled a few pieces in our plan. We're able to display a greeting to the console. We're able to create a string that includes the user's name. And now we're on to the final piece, which is, well, how are we going to get this input from the user into our program so that we can use it? And so going back to our code, everything here is fine, except for what we're doing here on line 10. Rather than just assigning the literal value of Jane, which again is no different than our original solution, or that single line that we had there when we started, we want this input to come from the user. And again, this is pretty straightforward, luckily for us, and it's part of why we choose to use console applications to deliver these lessons. All of the interaction, both input and output with the user, is going to happen on the console. So you can see here on line 11, we're using the console to write a line so that the user can see it. But we're also going to be using the console to read in values from the user. And we have a string value, and it just turns out that the console has a method that will read in a string value from the console whenever the user inputs it. So how we utilize that is, again, we call on our console object. So console, capital C, that brings it up. We can see the little IntelliSense drop down there. And we want to access a method on that object. So we hit the dot operator. And remember, that's how we get access to the different properties and methods that are available on this object. And there's a number of them there, but the one that we're interested in is this top one for me. It's likely top for you too. Readline, capital R, capital L, again with the naming conventions. So yeah, that's what I want. You could either type that out, or if you see that in the drop-down IntelliSense list, you could click on it, or if you press the tab key, it'll complete that for you. Okay, so that's just me hitting the dot and pressing tab because that was the highlighted option. Again, we could just type it out, but as you type, you'll also notice that it narrows down the available methods based on what you've typed here. So as soon as I type in read L, there's only one that matches, and if that's what I want, I can press tab at that time and it'll complete it for me. Okay, now readline is a method, and how we call methods is to always include the parentheses on the end. And so right now this is giving us a red message, a red underline, because there's an error. We're not using readline in the appropriate way. It's not a property, it's not a value that we can read, it's a method we want to call. And so if we complete that with the open and close parenthesis on the end, you'll notice that all the error underlines go away and everything is back to fantastic. So far so good. We're almost there. We are so close. If we run the program now, so we can save it, Control S, we can choose to play our program. It's going to work and it's going to do exactly what we've asked it to do, but it may seem a bit strange. So I'm going to play this and I'll pull it over. And if your screen is looking like my screen, don't fret, don't feel frustrated or think something's gone wrong. The program is doing exactly what we've asked it to do. And if you go back and look at our statements, we'll see why. The first thing we're asking for in our program, after we have declared the username variable, is we get to a statement where we're saying, hey, we want to assign username the variable a value, and that value is going to be coming from the console. So that's what it's waiting for. We have our blinking cursor here because the program is waiting for us to enter some text and then press the enter key or the return key if you're on your Mac. And so this isn't really the best for user experience because if I had not written this program, I would have no idea what I'm being expected to do here. But if we go in and we type in our name and then press enter, you'll see that that reads that value in, uses it in our expression to create the greeting string, and then it writes that string out to the console. So everything is working exactly as we've typed it out here. And this is one of the hurdles that people that are new to programming often struggle with is the computer will do exactly what you say and no more. It's not intuitive. It's not going to think, whoa, right, you probably mean to do this. Doesn't happen that way. It does exactly what you've typed in for the instructions. So in this example, I don't want it to just come to a blinking cursor. I want to inform the user of, hey, this is what you're expected to do. So let's add in what I like to call a prompt statement so that we've given the user not only some output, but also some indication that we're waiting for them to perform some kind of action. So again, we want to display something. So, oops, and I'll do this after we've declared our string variable. So we declare the username. Before we can input that value, I'm going to go to my console, and I'm going to use here the write method. I'm not going to use write line. Okay, and I'll demonstrate why I'm choosing to use write versus write line in just a moment, but there's a very good reason for this. So to the write method, again, we can pass in a string literal value, and what I'm going to type in here is a command or a request, if you will, to the user to enter your name. I'm going to include a colon and a space, and you'll see why that's important in just a moment. And that's enough to display the request to the user. So now they're not just going to see a blank screen with a blinking cursor, They're going to see a prompt so they know what to do and what they're expected to do, and it'll be a bit smoother of an experience versus just having a blank screen. But we'll see the effect of using the write statement versus the write line statement right now. So let's just run this program with our update. Okay, and now we can see instead of just that blank blinking cursor, we actually get a prompt, enter your name. And now, because we've used the console.write method, it doesn't write that string in a line and drop the cursor down to the next line. It just writes out this string, but you'll notice it leaves our cursor right on the same line as the output. And I like this as a prompt mechanism because I'm able to type in my value right beside the prompt. It looks clean and makes a lot of sense. I don't like writing the value in on the next line. So we're asked, enter your name. I enter it exactly right on the same line, and then I press enter, and then we get to see our greeting string. So at this point, we've kind of knocked out this program. Again, it was very simple and straightforward to begin with, but it allowed us to cover these three pieces that are very typical of pretty much all the programs we're going to create, and that being creating variables, getting input from the user, and displaying output to the user. Those are three kind of foundational pieces of almost all of the programs that we're going to create over the next 9 weeks together. So if you were able to follow along so far and feel pretty confident, then you're doing great. Really all we're going to do from here on out is just wash, rinse, and repeat. We'll be adding more variables of different types. We'll be doing some arithmetic, but at the end of the day, it's really just more of this. So before I let you go, let's just go back and explore a couple of things. So I'm going to close this output. And what I want to do here is just demonstrate what would happen if we use, instead of write, we use write line for the prompt string. So this is still going to work. There's nothing wrong with it. The program isn't going to break, but the experience is a little bit different. Okay. So here again in the output we can see it asks us to enter our name, colon, but because we used write line instead of write, the cursor now for input is on the next line after. So if we type in the name of the user, it happens on the second line and then we get output. So again, not wrong, but not preferred. So for this course, I'm going to request that whenever you're prompting the user for input, you're always using the write method to output your prompt statement, and that the input value should be entered right here alongside. And again, best practice for aesthetics would be to also include that space character in your string for the write method, because if you don't, then the cursor is going to appear right beside the colon. Again, that's a preference thing. It's neither good or bad, but makes it clear to the user that there's a gap. We're being asked for something and that our input happens on its own. So I'm going to reverse this back to our write statement and save that. And so now we're kind of good here. We'll come back and we'll make one more update to this in a moment. But just to kind of clean up our plan, because now our statements are not directly correlated to the plan we created. Once we know now about variables and how we can prompt for input, we can make some changes to our plan here. So rather than just prompt the user for their name, I'm going to update that. I'll make it explicit here that this is the plan we're creating. And the first thing I want to do is I want to declare a variable. So I'm going to make that clear. I'm going to say declare username, and I'm going to declare that as a string. So this is just a pseudocode syntax that I like to use. You'll notice that it is entirely different from the C# code that I've just created, but that's because the pseudocode plan is a plan for how I would program this generally. It says nothing about the actual language that we've chosen to use. So the solution we have is in C#, but there's no reason why I couldn't write this program in Python or Ruby or JavaScript or some other language. That doesn't really matter. What I care about at the planning activity stage is just that I'm explicit and clear so that whatever programming language I do choose to use, I know exactly what it is I'm about to do. So I'm going to declare username as a string. That's what I'd like to do. And then I'm going to say explicitly here, I'd like to prompt for input. So I'm going to just type in here prompt, and then in quotes, whatever the prompt string is that I'd like to use. So I asked in this example to enter your name. And then after the prompt string, I indicate what variable I'd like to store that in, so username. So when I see this in my pseudocode plan, I'll know right away that, oh, this is going to be in C#, a console.write statement, and I'm going to have to assign the read in value to this username variable that I declared previously. This final step here where I'm creating the greeting string and then displaying it, I'm really just doing that in one step. And so this is fine kind of as it is, but it's not explicit about what the values should be. So there's two ways we could go about doing it in our plan. One of them is we could declare a second string variable, that is the greeting string. And what we could be doing here is assigning that a value, which would be the hello and then concatenated with the username value. And then finally here, I could say display, greeting string. That's a way we could go about doing it. Or we could recognize that I don't really need the greeting string anywhere other than where I'm displaying it. So we could just display it straight away. So the plan could also look something like display, and instead of the greeting to the console, I can be explicit and just say this is going to be hello, and with a space, and then I'm going to concatenate username to that greeting. And so now when I see this, I'll understand, oh, this is going to be an output statement. There's a string literal and concatenated with this variable, and then that correlates one-to-one with what we can see in our code here. So again, any one of those several solutions I have indicated would work are fine. I'm not interested in you coming up with plans that are identical to what my plan would be. I'm interested in seeing you develop plans that are valid, that work. And there may be 10 of you that work on a problem, and each of you comes up with a slightly different way to solve the problem, but each of those problems may be equally valid, and there's nothing wrong with them. We might have a debate over which one is more efficient or follows more best practices, but those are discussions that we'll have later on in the course. They're not really important for now. So what we can do once we've put all this together is we can just save this up. We can store our project somewhere on our file system so that we have access to it again in the future. And then I recommend that you come back in here to these programs and then make adjustments and make changes so that you can practice and build up your skills programming. One final thing before we do end this video is I also just want to update you on how we could have shrunk this program a little bit more. And that is by not only just declaring the string on its own, the variable, but also declaring and assigning it a value at the same time. So that was something I kind of skipped over earlier when we just created the variable and assigned it the value of Jane. But sometimes you'll want to initialize a value right when you declare it. And it's possible to do both the assignment and the declaration of that variable in the same line. So if you wanted to get a bit more clever, we could have declared the string username and assigned it the value of console readline in the same statement. So rather than declaring the variable above here, if I highlight and Control X, I'll just cut that out. We could have displayed our prompt string and then here said I would like to just declare a variable of type string. The variable is a username, and I'd like to initialize it with whatever value the user has entered. Okay. Again, this is equally valid to this program solution that I just had there. If you make that update and you run this program, it's going to run. We're going to see our prompt string. I'm going to be able to type in my name and press enter, and it displays, and everything is great. Okay, so again, equally valid. But what I've done here is rather than have an explicit declaration statement and then a follow-up assignment statement, I've declared and assigned in the same statement. My preference is not for this in the solution. In larger programs that you're going to create, if you're declaring variables kind of nested within your code, it can be difficult at once to look at the program straight away and have an idea of what all the moving parts are. So while it's not wrong, I would recommend that at least in the beginning, while you're still learning, you try to get comfortable with identifying variables that you'll need in your program and declaring them prior to where you're going to use them later on in your code. And I'll also be using white space to kind of group several statements together that logically appear to go together. So for example, I might finish this program up by separating the code like you see here, where I've got my declaration of variables and then I've got some separation. These two lines I've grouped together. This is my prompting of input, so I'm displaying this prompt string and inputting a value. That represents kind of this single task of prompting for input, and then I've got a space which separates my prompting for input from my display of output. So again, those are things that are just preference. The computer doesn't really care about that, but as a programmer and a developer, if I've got to read your code, or even you have to read your code in the future, following these best practices of naming meaningful variable names, following the indentation and code standard guides, using white space to group logically the statements together is going to make a lot of sense, and it's going to make it really easy for you to read through the code and understand what's going on there. So I hope you found this informative. That's basically it for introduction to using variables, and in this case particularly string variables. We looked at how we can prompt for input and capture input from the user, and we also looked at how we can take variables and we can concatenate them for output back out to the user. So go ahead, look in the practice solutions, the practices folder, and pull up some programs and see if you can't experiment with this a little bit. And I'll see you in the next video.